examples of how this works. Like if I had this the square root of -1 and I cubed that, that would be that would become it actually would be the product of these two, because this is to the first power and that's to the second power. So it actually would become -I. And then if I did this again to the fourth power, that would be like having two of these. So -1 times -1 would be 1. So it's probably better just to explain this once you understand it as saying, instead of using the square roots all the time, because the whole point is to use the notation I, is to say that I to the first power is its own thing, it's I. But I to the second power goes to a real number of -1. I to the third power would be a product of these two, because 3 would be 2 times 1, so it comes out to -I. And I to the fourth power would be like having I squared times I squared, or -1 times -1, or +1. And believe it or not, that cycle, it just continues. So if I were to take a look at the next set of this, if I had I to the fifth power, right, I to the fifth power would be like multiplying I to the fourth and I to the first together, so we would be right back at I. And I to the sixth power would be like multiplying. You could do it two different ways. You could do 3 cycles of this, is probably the easiest way, because 6 would be this times itself times itself. So -1 times -1 times -1, hey, we're back to -1 again. And I to the seventh power, take a lot of ways to do this, but let's start with the originals. It would be like multiplying I to the third and I to the fourth, so that would be again back to -I. And then I to the fourth power is like multiplying, I to the eighth power is like multiplying I to the fourth power twice, which would just give you 1, because 1 times 1 is 1. And that just keeps going. So if I went to I to the ninth, you can go through the math if you want, but big surprise, that would be I. And I to the 10th, big surprise, that would be -1. I to the 11th would be -I. And I to the 12th would be 1. So what's happening? Why is this happening? This is a cycle of numbers. It is a number that is cyclic, and it repeats itself in a cycle of 4. If you want to know what this is algebraically, it actually is something called modulus, which is used in computer science. It is the remainder that appears when you divide. So the way that this works is, if you have a remainder of 1 when you divide, you cycle to the beginning of the cycle, so you'll have I, just like we did here. If you divide any of these numbers, right, by the fact that there are 4 things in here, your remainder will be 1. If you divide this and get a remainder of 2, you'll have -1. Remainder of 3, you'll have -I. And it's not 4, because if you divide any of these last by the fact that there are 4 different examples of answers, 4 divided by 4, 8 divided by 4, 12 divided by 4, they all have a remainder of 0. So if you have a remainder of 0, then it cycles down to 1. So I'll give you an example of that. Let's just pick any one in this set. So 12, 13, 14, 15. So let's say I had I to the 15th power. Okay, and so we already know the answer because we can see it in our little setup here. It's going to be -1. But because there are 4 different combinations, we're going to divide 4 into 15, because there are 4 combinations, and we're looking for the 15th. What does it do? 4 will go into 15. Of course, it goes in there 3 times, right? And so we subtract that product, and we have a remainder of 3. Well, this remainder indicates that it's the 3rd member of the cycle. So if you have a remainder of 3, you would have -I. So we already knew that because it was in our little chart there. But what if we had larger versions? So why don't we take look at some examples of, and this happens sometimes on standardized tests. Someone will say, what is I to the 15th? So we just did that one. Again, to show you, you take 15, you take the fact that there are 4 in the cycle, 4 goes into 15, just like in elementary school math, it goes in there 3 times. We look at the remainder is 3. So if this is our remainder, it tells us to go here, so this equals -I. So the 28th power, again, we're dividing by 4 because there are 4 different ways that I can turn out. It goes in there exactly 7 times. And when that happens, that means that we have a remainder of 0. and 0 means that we're at the end of the cycle. And that's the case for anything. It's hard to explain for kids who are not in computer science, but that's a very important thing to understand when programming. So let's do 22. If I divide 4 into 22, it goes in there 5 times. The remainder would be 2. So that would come out to -I. This one I did because you can just spot check that that's going to have a remainder of 0. So you know that's going to be 1. Anytime you divide any of these by 4 and get 0, you have 1. And then we have this last one just to show you that, some people might actually make out a chart for some of those, but I mean, that would take a really long time. So I showed you this one with 113 in it. So 4 goes into 11 twice. That would give us an 8. Then we would have 33. And then 4 goes into 33 8 times. So we would have a remainder of 1. So that goes back to the beginning of the cycle. Evidently, this equals I. So sometimes kids have trouble understanding why I'm dividing by 4. And the reason I'm dividing all of these by 4 is because when we started going through the cycle, we only had 4 possible values. So you're trying to figure out which of these 4 values that any of these particular numbers are. And that remainder corresponds to the correct value.